Hello and welcome to the video on solving quadratic equations. We're going to go over several different methods for solving them, including factoring, square root, and the quadratic formula. Then we're going to do an example story problem. Let's go ahead and get started. So remember, quadratic equations are of the form ax squared plus bx plus c equals 0, and a, b, and c are all real numbers. So there is a lot of different ways to solve them, and we're going to just focus on, like I said, factoring, square root method, and using the quadratic formula. So let's start with factoring. The key to solving quadratic equations by factoring is to remember the zero product property. And what the zero product property says is that if you have two numbers and they multiply to 0, then one of them has to be 0. So if we look at our example 1 here, we see we have two things being multiplied together and they equal 0. So the first factor that we have is x minus 3, and the second is x plus 2. If those two quantities multiply to get 0, that means one of them must be 0. So that means that either x minus 3 has to be equal to 0, or x plus 2 must be equal to 0. Well, we can all solve these pretty easily. The first one's going to be 0 when x equals 3. And the second one's going to be 0 when x equals negative 2. Subtract 2 from each side. So that means our solutions are either x equals 3 or x equals negative 2. So if we have our quadratic equation already factored, it's very easy to use the zero product property and solve it. So now let's make this just a little bit harder and start with a quadratic equation that isn't already factored. So let's look at the second example here. And it says x squared minus 4x minus 21 equals 0. And the goal here is to write this as the product of two quantities, and then we'll use the zero product property. Well, let's think about what these two quantities are. The first term, so if we're thinking about the opposite of foiling, when we FOIL things out, we would go first. So if we look at our up one here, we would first, and that would give us our x squared. Well, we have an x squared here, so we know that these two quantities must both have an x. So that's our first, and then also in foiling, we have our last. So we know that these two numbers need to multiply to give us negative 21. So there's a couple different ways to multiply to give you negative 21. You could have 7 and negative 3. You could have negative 7 and positive 3. You could have negative 21 and 1, or you could have positive 21 and negative 1. There isn't too many factors of 21, so those are sort of our options. So we need to choose which of these two pairs is going to give us our cross terms that add up to negative 4. So I'm going to think about it's got to be x minus 7 and x plus 3. Because if I check that by foiling it out, and I'm just going to switch to another color and foil this out, x squared plus 3x minus 7x minus 21 equals 0. That gives me x squared minus 4x minus 21 equals 0, which was our original problem. Now, if you're very rusty on factoring, this is going to feel very fast to you. I encourage you to reach out. There's some extra factoring videos in the Canvas shell as well. I'm not going to spend a lot of time on factoring here because that technically is a prerequisite topic. But if it's a topic that you need to review, please reach out and let's get you reviewed and caught up on the factoring. All right, let's try another problem. Let's look at this one right here. Well, I didn't finish this problem. Back up. Let's finish this problem. So let's make a little space for ourselves here. All right, let's go ahead and finish this problem. So we had it factored from here. Let's just move over here. We had x minus 7 times x plus 3 equals 0. We use our zero product property, so either x minus 7 is 0 or x plus 3 is 0. This means x is 7, and this would mean x is negative 3. So those are my solutions to this equation. X equals 7 or x equals negative 3. Right now, I'm going to check my work just really quickly in the space below here. And let's go back to our original equation, which was x squared minus 4x minus 21 equals 0. And I can check my work with either. I'm going to go ahead and check it with 7 and let you guys check it with negative 3 on your own. So if I plug 7 in for x, that would give me 7 squared minus 4 times 7 minus 21, and question mark, is that equal to 0, is 49 minus 28 minus 21 equal to 0. And sure enough, it is. So that answer checks out. You can go ahead and check -3 too to make sure that it works. All right, let's try this next example 3. It's a little bit harder. And what we'll notice right away is it's not set equal to 0. But when we defined quadratic equations up ahead, we did have them equal to 0. They don't necessarily have to be equal to 0. They just have to be able to be put into that form. So when we solve by factoring, this first step is always going to put it into the form where it equals 0. So my very first step before I can even factor this one is to set it equal to 0. That's going to be my very first step. So that way I can factor. It doesn't help to be set equal to -15. There's not a -15 product property. It's the 0 product property. So I need the two things to multiply to be 0. So let's just add 15 to each side, and that gives me x squared plus 8x plus 15 equals 0. And now I'm going to factor these terms. I need to think about two numbers that multiply to give me 15 and add to give me 8, and that's going to be 5 and 3. So using my 0 product property, I know that either x plus 5 is 0, or I know that x plus 3 is 0. So x is either -5 or x is equal to -3. It's always a good idea to check this. Let's go ahead and check it really quick using our original equation. I have a little bit of space right here. Let's check the -5 value. So is -5 squared plus 8 times -5 equal to -15, question mark. I always check with the original equation, so there's no chance that I made an error. So 25 minus 40 is that -15, and sure enough it is. Check. Excellent. Let's keep going. Now, in these two previous factoring examples, my leading coefficient was 1, in that if you see, actually all three of them, if you look up front of the x squared, there was just a 1, which makes the factoring quite a bit easier. What do you do if it isn't a 1? Well, one method that we talk about using is called the AC method. I'm going to do one example of the AC method for factoring. So the AC method works like this. If this is my a, and ax squared plus bx plus c equals 0, I'm going to compute what a times c is equal to. And in that case, that's equal to, in this case, a is 4 and c is 9. So a times c is 36. Okay, so I found my AC value, which is 36. Now what I need to do is I need to find two numbers that multiply to 36 and add up to 15. So I need to find two numbers that multiply to 36 and add to the b terms, which in this case is 15. Oops, hang on, squish that in a little bit. And add to 15. So in this case, let's think about two numbers that multiply to 36 and add to 15. Well, 1 and 36, nope. 2 and 18, no. 3 and 12 seem like a good option. So 3 and 12 multiply to 36 and add to 15. So now what I do is I write my equation as 4x squared plus 3x plus 12x plus 9 equal to 0. All right, so I've split that middle term up. It's still equal to 4x squared plus 15x plus 9, but it's written as 3 and 12. And now I'm going to go to factoring by grouping. And if you don't remember factoring by grouping, please go back to our Canvas shell. There's going to be a video on it that you can watch and review. So I'm going to group my first two terms, and I'm going to group my last two terms. And I'm going to factor an x, the greatest common factor, out of my first terms. And I'm going to factor a 3, which is the greatest common factor, out of my second two terms, which conveniently leaves the same thing behind. So when I factor out the greatest common factor out of both groups, I get left with 4x plus 3. So that becomes my first factor, 4x plus 3. From the first term, I have an x. And the last term, I have a plus 3. And now I have factored this quadratic with a leading coefficient that is not 1. If you need to review this method, there are videos that goes over this and a few more examples. It's easy to find. All right, let's keep solving. We need to use the zero product property now. So 4x plus 3 equals 0, or x plus 3 equals 0. So solving the first one, 4x equals negative 3, divide by 4. X equals negative 3/4, or x equals negative 3 are my two solutions. Again, you should go in and check your solutions. I'm not going to do that right now just to keep this video a little bit shorter. All right, that is solving quadratic equations by factoring. Let's talk about our second method, which is the square root method. The square root method only works in quadratic equations that have the b coefficient equal to 0. So if you look at example 5, it's ax squared, no bx, minus or plus c equals 0. So if I was labeling a, b, and c here, I would have, why is mine a? Okay, my pen just quit working. A is equal to 3, b is equal to 0, and c is equal to negative 27. So you have to have that b term equal to 0 to use the square root method. And the square root method, you don't set it equal to 0. The square root method, you just isolate the x squared. So the first thing we're going to do is add 27 to each side. And that gives us 3x squared equals 27. We haven't quite got the x squared isolated yet, so let's divide both sides by 3. X squared equals 9. And now we take the square root of both sides. X equals plus or minus 3. And those are my two solutions for this quadratic equation. Again, I encourage you to check those. Let's try another square root method example. Why don't you give this one a try? Jump in and give it a try. Pause the video and see how you do. All right, how did that go? Did you add 16 to each side? Yeah, most people like the square root method. It's pretty quick and dirty. All right, square root of both sides, and we get x equals, don't forget the plus or minus, 4. So two solutions, plus 4 and the solution minus 4. Let's do one more example of the square root method. All right, let's give this one a try together. I'm going to subtract 12 from each side. Minus 4x squared equals negative 12. Divide by negative 4. X squared equals 3. And take the square root of both sides, and x equals plus or minus, well, there is no whole number that is the square root of 3. So I'm just going to leave it as the square root of 3. That's an okay number. You can just write square root of 3. If you're solving a story problem or something like that, it's okay to find a decimal approximation. I looked this up. You could write x is approximately 1.73, or x is approximately negative 1.73. Those are approximations, not exact values. This is my exact solution. If they asked for exact, plus root 3 minus root 3. All right, let's talk about our last method of solving quadratic equations, and that's using the good old quadratic formula. All right, let's just, there's the quadratic formula. I encourage you right now, if you do not have it memorized, this is something that should definitely go in your note card for the first test. Absolutely. And let's just jump in and try and solve it. All right, let's label our A, B, and C. A in this example is 1. B is 5. C is 1. And let's jump in. So our solutions are x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. All right, well, let's just do some simplifying. That's going to be 25 minus 4 all over 2. So that's, and I got a little bit carried away with my square root sign, but that's okay. Minus 5 plus or minus the square root of 21 over 2. And honestly, that's about as good as this is going to get. The square root of 21 isn't a perfect square. It's between 16 and 25, which are our two perfect squares. Its factors are 3 and 7. Neither of those are perfect squares. There's really not much you can do to make this a better, a more simplified solution. So I would leave it there. Let's go ahead and try another one. All right, this one also is not set equal to 0. So with factoring and with the quadratic formula method, you do have to set the quadratic equations equal to 0. For the square root method, you don't. So the first step in this one is going to be set this equal to 0. All right, why don't you jump in and try out finding A, B, and C and plugging in the quadratic formula. Pause the video, get that work done, and then we'll go over the answer in just a minute. All right, how'd that go for you? So my A was 1, my B is 5, and my C is -2. So let's go ahead, and that's x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Oops, I wrote the wrong thing down. Hang on. All over 2a. So that's x equals minus 5 plus or minus the square root of 25. That's going to be plus 8 over 2. I got really carried away with the square root sign on that one. Let's just trim that down a teeny bit. And that's minus 5 plus or minus the square root of 25 plus 8 is 33 all over 2. And again, there's really not much you can do to simplify this down. Or nothing really, no nice perfect squares go into 33. All right, let's keep going and talk about a real-world application to a quadratic equation. So here's our last example. An epidemiological study of the spread of a certain strain of influenza that has hit a small school population found that the total number of students P who contracted the flu T days after it broke out is given by this function, P of T equals minus T squared plus 13T plus 130. So where 1 is less than or equal to T is less than or equal to 6. So let's think about this for just a little bit and think about the problem. So T is the number of days after the flu broke out, and P is the number of students who have that flu. We're going to graph this over 1 less than or equal to T less than or equal to 6, so approximately 6 days. So let's go ahead and go to Desmos and graph this function. It's negative T squared plus 13T plus 130. So I'm going to pull up Desmos, go open my graphing calculator, and I'm going to put in P of T. Hang on a second here. P of T equals, and I already forgot it. Let's just look it up again really quick. Minus T squared plus 13T plus 130. Let's see, is that right? Minus T squared plus 13T plus 130. And we're interested in the values between 1 and 6. Well, looking at this original graph, it doesn't really show anything of what I want. But remember, I'm interested in the domain from 1 to 6. So I'm going to go ahead and set my window for that. I hit the little wrench bar button up in the right-hand corner. And I'm going to go to my x-axis. And I'm going to take it from -1 to 7. To start with, and then I don't see anything on my y. I'm going to let that smallest value be like -10 and my largest value be 150. Now, that looks pretty good. I thought those numbers, the t values came from the problem, but if I look at the P of T function, when t is 0, I know it's going to be at 130, so I know the students are going to increase in their flu outbreak. So then I just zoomed out a little bit, and there's my graph from 0 to 6. All right, find the day on the graph where 160 students had the flu. So if we want to know the day where 160 students had the flu, let's go ahead and just trace along the graph. The nice thing about Desmos is you can just go along and it tells you the XY values. It looks to me that on day 3, 160 students had the flu. I can check that by using function notation in Desmos and put in P of 3, and it tells me that that is in fact 160. So graphically, I found where the 160 students had the flu, and that was on day 3. And finally, they want me to solve for this algebraically. So let's go ahead and do the algebra to solve for this. So what I want to know is when P of t equals 160. But P of t is given by this function. So I want to know when that function equals 160. All right, so the first thing I'm going to do is I'm going to set this equal to 0. Oh, sorry, subtract 160. And so that's now equal to 0. So minus t squared plus 13t minus 30 equals 0. And now I can use the quadratic formula to solve this. All right, now we've set it equals 0. We find our a, b, and c. A is equal to -1. B is equal to 13. C is equal to -30. Plugging this into the quadratic formula gives me minus b plus or minus the square root of b squared minus 4ac all over 2a. 13 squared is 169. Negative 4 times -1 is positive 4 times -130 is -120. All over -2. All right, let's keep going. T equals -13 plus or minus the square root of 169 minus 140 is 49 all over -2. So this is equal to -13 plus or minus 7 over -2. So t is either equal to -13 plus 7 over -2 or t equals -13 minus 7 over 2. So looking at this, -13 plus 7 is 6. -6 over 2 is 3, and that's the answer we found graphically. Thinking about this one, we get -20 over, I'm sorry, that should be a -2, and that is 10. So this function only was defined on the domain from 1 to 6, so we can't use this 10. However, if we did have the model extended, let's go look at the graph really quick. If we did extend the model on out, we'll see that as the flu cases started to wane, here at 10, we also got back down to 160. So that's what that answer is coming from. But this story problem really was only defined between was only defined from, oh my goodness, stop doing that. This story problem was really only defined from t equals 1 to 6. So we're going to pick the t equals 3 answer. All right, this was a review of the quadratic formula.